Hi, hello, Dr. Wang here. I'm going to do a quick tutorial for how to complete simulated restriction digestion for lab report lab 324. Usually we would use SAPIO, but currently we're experiencing some technical issues. And the first alternative to SAPIO, APE, seems like some students have issue installing it. So here is another alternative. This is called Restriction Analyzer. If you go to Book Bioinformatics, you're going to see a link to this web-based software. So I'm going to open this link in the new tab. This is what Restriction Analyzer looks like. So the sequence that we will be analyzing are located on Canvas. If you go to week 4, go to day 2, and then under Plasmid Editor 2 annotation, there is a page called sequence file for Plasmid Editor 2. When you open this, you're going to see 3 files. The file we need are PMSH2, FASTA format, and then PRS413. So PRS413 is the empty vector without any insert, and PMSH2 is the vector containing MSH2 coding sequence. So over here, we do have a third plasmid called PMSH2 prime, which is the mutated version. We don't really have a sequence for it currently, but it's going to behave exactly the same as PMSH2. There's only a single base difference between these two sequences. So when you perform restriction digestion, this two looks just the same. All right, so I already have these 2 files downloaded on my computer. This is my download folder. You can see these 2 files. You simply click to download. Once downloaded, I have a Mac, so I'm going to open this with a text editor. So here, this is the sequence file, right? So here I'm simply going to select all the sequences and then copy all the sequences and then come back to the restriction analyzer. So here I'm going to paste the sequence right here. Right, so it looks like so. And then down here, we are going to make sure that we select circular, right? Because this is a plasmid, so it's circular. And another thing we're going to do is we're going to use a user provided list. So I'm clicking enter the restriction enzyme list. Over here, I'm going to enter the 2 enzymes we used in the lab. This is APA1 and XPA1. So for number 1, this is a Roman numeral, so it's capital letter I. Save and close. All right, so now I'm going to basically use the user provided list that has those 2 enzymes. So now basically, right, so everything is done. I'm going to apply and analyze. So down here, right, so here this is a simulated gel. So we're doing a double digest. So I'm going to select the first enzyme and then also select the second enzyme. So this is what a double digest looks like. So you can see PMSH2 plasmid DNA digested with 2 enzymes will produce 2 fragments, and this is the simulated gel. So please copy paste this gel image into your lab report under the simulated gel, and the fragment size is red right here in red, right? So we have 2 fragments. You can see both are located in between 4,000 and 500 base pair letter, and then their size is one is close to 4,900, the other is close to 4,400. All right, so then the next step is to just perform the same step for PRS413. Here is your second simulated gel image to put into your lab report. Okay, so once you are done with your analysis for the 2 simulated gel image and also your analysis for the actual gel image, you're going to compare the 2 and reach a conclusion. For example, if you have sample 1, 7, 13, right? So just for example, right? So what is sample 1? Is it PRS413? Is it PMSH2? Is it PMSH2 prime? And also, can you distinguish PMSH2 from PMSH2 prime?